Hi, folks. Thanks for joining in. Hope you are doing great and most importantly, staying safe. I'm Prabhas Sirivadana from WSO2, and this is our 37th Silicon Valley IAM meetup. Today, we have O'Priel to talk about hidden risks of managing IAM in the cloud. O is the VP of Product Management at Hermetic. And before that, he worked for Palo Alto Networks for over 6 years, leading various projects in different roles. With that, I'll hand over to O. Over to you.
Thank you very much.
In the cloud. O is.
Are we good?
Yeah, we are good.
Sorry. So thank you again, and thanks for everybody listening in. Kind of to give a background about what we're going to do, I'm going to try to walk a little bit through a story and walk through the evolution of securing really your AWS environment more from a identity perspective. I'll do this a lot using the AWS console. I'll try to minimize slideware. In the end, I will talk a little bit about the remediate platform, the company that I currently work for, and the company that I'm part of the product management team for. We'll try to do this as interesting as possible. If there's questions at any given point, I'll be happy to answer. Answer them. So just interrupt me, and we'll try to do this as flexible as we can. Okay, so kind of starting off, want to kind of run through the history of really breaches in the cloud. So we'll start off with really what started the cloud breaches, and of course this is our opinion, was really the beginning with a very, very infamous hack, I'll call it, of a company called Codespaces. Basically what happened there was they failed to do the bare minimum, which is securing access to their console. What happened was an attacker actually got into their console and from there took their entire infrastructure as hostage. It actually ended up with them having to close down their business because they had no recovery plan for a scenario like that, with somebody hijacking all their infrastructure completely. It was a super interesting breach. I highly recommend reading about it. It's not very technical. There's nothing super interesting, but it's the outcome of it is what I think makes it very interesting. There was the term that got coined for it, which is murder in the Amazon cloud. So that's really what started, I'd say, the big breaches in public cloud. Then after that, for a few years, the leading cause of breaches was really leaving sensitive S3 buckets open. Probably all heard about the Experian hack and the fact that almost everybody's records got leaked from that hack. But a really interesting actually hack was the Accenture one. The Accenture one is interesting specifically because what they left open was really data around a lot of their, I'm going to call it customers. So that led to a lot of different breaches just because of that one breach. But really, again, the point was just leaving S3 buckets open to the public and not properly securing them. Then the next thing was really databases in general. So leaving databases unsecured and not properly securing them, which very similar to the S3 was just a new fad, and hackers tried to target those constantly. Now, this all leads us really to what we call sort of the latest evolution of these attacks, which exemplifies in the Capital One breach that happened in 2019. So the Capital One breach is an interesting breach for us specifically because it really talks about our main focus. So to kind of explain what happened in the Capital One breach. So the Capital One breach was basically what happened was they had an EC2 server that was open to the public. That EC2 server was running a WAF. That EC2 server had permissions to access a lot of their environment. Specifically, what became public was an S3 bucket. That S3 bucket contained about 100 million records of their credit card customers. And what actually happened from a technical perspective was the attacker compromised a vulnerability on that WAF server, basically got access from there to the EC2 server that WAF was running on. then used the privileges granted to that EC2 via the role that was actually associated with that EC2 and started traversing the environment. He found the S3 bucket and then exfiltrated all the data out. Now, this is very interesting to us, not because of the vulnerability. Vulnerabilities are there constantly. There's a lot of tools that are there to help mitigate the vulnerability. But to us, it's really interesting is in order to understand, why did an EC2 that is internet facing have permissions to one of the most sensitive resources in the Capital One environment, this S3 bucket? Now, specifically, this S3 bucket wasn't open to the internet. There was no access to it. So from an S3 perspective, the Capital One team did everything right. It was secure, it was closed. The problem again was that connection between that open EC2 server to that S3 bucket. So really, the problem that we're trying to explain here is really understanding why is it so difficult to actually manage identities in the public cloud. We have this little image on the right that you can see right now on the screen, which kind of shows the relationship that we have between services to roles to other services. Then you have to throw in human identities here and how they interact with the entirety of the system. And as you can see, just from this little snippet, there's a lot of components. There's a lot that you need to track. There's a lot that has to be followed in order to really understand what's happening from a privilege perspective in your environment. You're left with questions like, who has access to what? Who's actually using the access that they have? And then you need the context of where is my sensitive data located? Do I have an open S3 bucket, a very sensitive S3 bucket associated with a machine that is publicly exposed? Those are the questions that really a lot of organizations are left asking. And fortunately and unfortunately, AWS tries to help. It doesn't go all the way, and I'll kind of try to show how AWS does this and what they can help with. But it's a very complex and not an easy task to really solve. So what we're going to do really now is we're going to go through like a few different, I'm going to call it scenarios, and really go through them and try to understand how we can use the tools that are there today in AWS to really help us and understand really answer those questions. So the first step is we're going to try to map all existing permissions. Then the second step is understand who's not using them. Then the third step is really remove all excessive permissions. Each step is going to have additional underlying steps within it, really. But we're going to start off with step number one. So we're going to take step number one and really dive down into a simple use case of really understanding what a specific user has access to. So I'm going to change my screen. And we're going to go to the AWS console. We're going to go to IAM. We're going to go to users. We're going to find the user that I have for this demo, which is this user. And we're going to look at what this user has. So for those really unfamiliar right now, we're in the AWS console. We're looking at the IAM service. We're looking specifically again at a user. And what we're seeing right now is basically the effective permissions that user has, or at least what we think are the effective permissions that user has. So we can see right away, we're in the permissions tab. We can see that he has multiple different policies attached to him. We can see that it has policies attached from the group. We can see that he even has a boundary, and I'll explain all this. So starting off with what is directly attached to him, which is the easiest. So we can see that he has one policy that is an AWS managed policy. To explain, an AWS managed policy is a policy that is created by AWS themselves, and you can basically inherit into your account and use it at your will. It is important to note that you do not control an AWS managed policy. It is controlled by AWS, meaning if AWS makes a change to that managed policy, you inherit that change. So it's something that organizations need to be aware when they use. The next thing is a managed policy. A managed policy is a policy that is controlled by my organization, is controlled by me. I created it. I can centrally manage it, which is an important differentiation from an inline policy. But it acts like any other policy. I can make a change to it in centrally under the policies menu, and it'll take effect everywhere. But it is a policy for just like any other policy. The next one is really an inline policy. The inline policy is a policy that is attached to a specific identity. In this case, it's only available to my user, the or demo user. Okay, you can see that I named it or demo inline policy. Again, I cannot centrally manage it. Like if I let's open another window. If I come here and I try to look for that policy, I will not find it. So you see, the only one that I found is or demo boundary. I can't actually find that policy because, again, it is attached only to my user. So the only way, and it's important to note, the only way to see inline policies is by going identity by identity, or even more specifically entity by entity, and actually understanding what policies they have attached to them. The next one is really just a policy that I have as a member of a group. So you can see that I have administrator access policy. That is an AWS managed policy that I got from the administrative group. And the next one is a boundary. I'm jumping a little bit ahead, but a boundary, just to explain, is, as it sounds, is basically a definition of the set of permissions that I can have at the utmost or at a minimum, really. So it depends on how the boundary is built. But in our specific case, the boundary sets only the permissions that I can have. So you can see it's effectively an allow, it's not deny, so it doesn't set the reverse. So these are only the permissions that I can actually have. So this is the boundary set. Boundary is actually stronger than all the rest of the policies. So even though this says I have administrator access, effectively, the boundary limits that to only these permissions. So from a user perspective, now we sort of have an idea what permissions he has, and we can a little bit really start to understand, okay, what can this user do or what can this user not
do? One question now. So all these policies, they are applicable to AWS resources, right? Or can they be used to define permissions to resources outside AWS?
So I'll answer this way. They're all AWS, so they can only apply to AWS resources. But when you're talking about third parties, in order for them to have access into your AWS environment, they have to assume what's called a role in AWS. Those roles are an identity. They're an identity type that carries permissions. So they can have permissions associated with them in that regard. So hopefully that answered the question.
Yeah, and do you have some examples for these three types of policies and when to use them, kind of?
So examples, well, you can see in front of you examples of the three policies. Where to use them really depends. I would say you want to minimize inline policies as much as possible, just because it makes managing them sort of a nightmare the more that you have. So having managed policies, I think, would be the most convenient. AWS managed policies are good to use, but again, you have to take into consideration that they're not managed by you. So the preference, and I think the best practice that we usually recommend, and even what our product does, is when it needs to create a policy, it creates a managed policy. And then it's just easier to maintain and easier to manage in general, because you could actually apply it to multiple entities. You could have really one single pane to view all your policies. So that's sort of how I would break it down.
Sure, yeah.
Okay. So now that we really have an understanding of, well, the user and his entity, we talked a little bit about roles, so I'll jump to roles. So roles, as I mentioned, are another identity type within AWS. So they have permissions associated with them. They are used by, as we mentioned, third-party entities. They're, I think, the most equivalent thing to what we would call service identities, really on the on-prem world. So again, we'll go and look for one of the demo roles that I have, and we can see that we have a role here that has a policy associated with him that is an AWS managed policy. In this case, it's Amazon EC2 full access. We can view basically the JSON, or easier in the UI just to view the policy summary and see what it can actually do. So we can see that it has full EC2 access. And basically, these are the permissions that are actually granted. Now, as I mentioned, this is a non-human, really, entity. What you have to do as part of a role is understand who is trusted to actually assume that role, who is trusted to act as if he is that role. So in this case, we go to the trusted relationships, okay, the trust relationships, and then we can see the trusted entities. In our case, the trusted entity for this specific role is that user that we looked at before. You can see that it says user or demo, and it is that user. So that means that when we looked at the policy from the user before, we didn't see any reference to this. But effectively, what happens is that user can assume this role, and all of a sudden, he actually gets the permissions associated with this role, which is this Amazon EC2 full access. So what we're seeing right now is basically the association to a role. Now, this doesn't have to be necessarily a user. It could be multiple different entities that are trusted. So if we go back here and we look at the other role that is part of my demo, we can see that this provides full administrative access. But the trust relationship here is interesting because there's two entities here. One is everything EC2. So all EC2 machines can actually assume this role and automatically elevate their privileges to full admin access. But if you notice, there is a role that we just saw before that can assume this role. So a role can assume a role. And what we're seeing right now is what we call role chaining. It's basically where one role can assume another role and act as if it's that secondary role. It basically, again, changes permissions and elevates its permissions to that level. Any questions or anything?
Yeah, so basically we can consider this AWS managed policies as a set of templates, right?
Yes. Okay. Yes, they are a set of templates. Everybody has them built out of the box. You can control them using service control policies and what they can and who can use them, but I'm not going to go into that right now.
Okay, got it. Yeah.
Any other questions?
No, that's it for now. Yeah.
Okay. Okay. So we talked a little bit about role chaining, and we talked about the concept of roles. Again, just important to stress out that you can have a user, you can have a machine, you can have another role, all as a trusted entity of another role. And again, once you assume that secondary role, you're basically acting as if you're that secondary role. And you get the permissions associated with that secondary role. So it's just a very important to remember this basically linkage between all these different entities. Okay, now we've looked at roles and we've looked at users. There's another set of policies that we need to take into account in order to really calculate what's going on, who has access to what access does my user have. So if we jump back into the AWS console and we'll do it for the S3 service, and we go to S3, and we'll look for my demo bucket. We'll see that my demo bucket also has permissions. Okay, now this bucket basically also has a set of permissions that I can associate with it directly. It is very much an inline policy of that bucket, so it's not publicly managed. There's no way to do that. But you can see here that for this bucket, both its user and the role have direct access and can do basically anything they want with this bucket. So you can see these are the two AWS entities, or the two AWS entities more accurately, that have access. They have all actions on S3, and basically they can do anything they want to this bucket. Okay, so this is an inline policy associated with this bucket. Now, again, it is different than the policies associated to my users. This is specifically called out on the bucket itself. So it's another thing to take into account, that when you look at policies in general, you have to also remember that some services do support policies directly on them. And at that point, you need to also go and check those to see what permissions they grant that are not captured in the permissions of the identity itself. So,
sorry, there's one question from Frank. How do roles relate to boundaries?
So it's a good question. So it depends. You could set, and I'll jump back, sorry. So when you go to IAM, you go to roles, and we'll go back to the role that I selected. You can set boundaries for a role specifically, but with that being said, if you assume, so let's say the user that we showed prior, the or demo user that we showed prior assumes the role that it has access to, which is this one or the other one, doesn't really matter if he just has to jump twice to get to it. The boundary is no longer effective because the boundary is set on the or demo identity. It does not limit him once he actually accesses a role. So boundaries are only effective on the identity that they are set on, basically. So the question is a great question because it's basically jumping way ahead to say that this becomes very, very complicated because even though we set a boundary on that user, he can effectively get out of that boundary the moment that he assumes any one of the roles that he has access to assume.
Yeah.
Any other questions?
No, that's it for the time. Yeah.
Okay. So we kind of jumped ahead to boundaries, and I was only going to explain this now, but basically just to really capture in short what we talked about. So we looked at a user with all this attached policy. We looked at a little bit about groups. We talked about it, receiving a policy from a group and the policies that could be attached via a group. We talked about roles. We talked about understanding role chains. We talked about resource-based policies, so the policy of the S3 bucket that I actually showed. We looked at boundaries, and I talked a little bit about service control policies, but I'm not really going to dive into that because I don't think we'll have enough time to capture all that in there. But those are basically this is just sort of the beginning of what you need to understand and all the relationships that are there in order to understand, okay, what access does a user have? What access does a machine have? How can they access different resources? So you really you have to map all that out. And if you notice, it took us about 20 minutes to do this for really one user. So this is a long and really tedious process to really go through. So now going back to the slide where, if you remember, we had the first step was really just understanding the user and understanding what he has access. The next step was really automation. So now, how do we automate some of this process using tools that AWS, tools that AWS really provide? So the first thing is, if we go back to the dashboard, we can go to a tool that, AWS provides, which is called the Policy Simulator. So Policy Simulator allows me to basically select a user. Okay, and it shows you all the different policies that are associated with that user. And then from there, I can select a specific service as an example. So let's do S3. And I can look at all the different actions. So these are basically all the different permissions that are available at S3. And we'll actually just select them all. And then I can run a simulation to see what policies does this user have. Okay. Now, what it does is it goes against the S3 service and checks to see if I have permissions or I don't have permissions. You can see that I'm getting an implicit deny for some of them, and I'm getting an explicit allow for some of them. But it's important to note that this takes into consideration, again, only the permissions set on the user itself. So it takes into consideration all AWS attached policies, all managed policies, all inline policies, the boundaries, group policies. It does not look, however, at roles and what I can do via an assumption of roles. It does not take that into account. So that isn't even calculated. And if you remember, I did have access via roles. It also doesn't take into consideration policies that are effectively applied to the well, a bucket itself, like we showed at the S3 bucket, and the fact that I could make all those changes to that demo bucket that I have. So that's important to take into account. But it starts giving you a sense of what I can or can't do if I was only that user and that's all I had. So that's a tool that is available and is somewhat useful, but just be aware of the limitations that it currently poses.
Yeah, one question. So all these policies, are they only role-based, or if we want to do something based on certain attributes, can we do that too other than roles?
I'm not sure that I understand the question.
Yeah. So if you look at a policy, it says, so if you have this AWS role, right? So this particular ARN, that this particular policy is applicable to you, right? So I mean, if you have this ARN, you can do these actions on an S3 bucket, right? Is it possible to define a policy based on certain other parameters, other attributes other than the role? For example, based on your email address or some other stuff, some other attributes other than the roles?
Well, so then it's not just based off of roles. You could do it based off of users. You could do it based off of different services. So there are other options. There's also the portion of conditions where you can set a condition that limits basically that policy. So there's multiple options that you can configure, and hopefully that I understood the question and answered. But there are multiple options. It doesn't necessarily just have to be a role.
Okay. Is it possible to open up that policy that you showed, maybe the inline policy for the S3 bucket?
Sure.
Yeah. So here the principal is an AWS role, right?
Yeah. So there's the role and there's the user. So you can see this is a role and this is a user. So I'm saying you can define multiple. You can define well, really other entities as well.
Yeah. Okay. It can be any attribute, right? Can we say like something email equals / something like that, or?
I don't remember if email you can do. It just depends on the attributes that you actually have within AWS. So it really depends on that. But I don't remember if you can do email or not. Maybe somebody online knows and can answer, but I just don't remember off the top of my head.
So if someone wants to define a policy based on the data outside AWS, is it possible?
Not as far as I know.
Okay. Okay. So okay, fine. So basically, so if you take something we have done before, so you can configure the login to the AWS Management Console from an external IDP, right? So then I can evaluate whatever the policy I need and assume a role to that particular person and send the SAML token, embed that into SAML token and send back. Then this policy can be evaluated against that role, right?
Yes. So for federation, you can assign specific access to the let's say to this S3 bucket to federated users. The way that you would do it is you would actually just call it out specifically. But in most cases, what people do is they actually federate into a role. Like, well, no, that's what happens. You federate into a role, and then you would assign that role access. The role could be located in a different account as well. It doesn't have to be associated. You can see this is all within my account. So this is the account number. You can see that account number up here. I can effectively do this to other accounts. Like you could be, it could be cross-account access, basically. That's sort of my point. So you do have that option. But even for federation, you would still call out a role here.
Sure. Yeah. Thanks.
Okay. So we talked a little bit about the policy simulator function and the fact that it can show me and the limitations that it has. So jumping back here, really one of the most I would say useful tools that is available to really start understanding a policy and how it's effective. But again, just remember the limitations. It doesn't take roles into consideration. at all. It doesn't take inline policies that are associated with a specific service into consideration at all. So it doesn't give you the full picture, but it gives you a somewhat accurate picture for really any service that you want to choose for the AWS services. So now that we looked at a little bit of the automation, let's go to the next step and understand how do we find out of all these permissions that this user or these roles have, who's actually using what, okay? So the first step is really understanding what can we do in order to effectively find out what that user is using. So I'm going to jump back here. We're going to go to IAM. I'm going to go to my user again. And I'm going to go show a tool that's called Access Advisor. So Access Advisor, just as it says up top, basically shows the services that I can access and really what I have or what I haven't accessed. So in this case, it's very easy. You can see that I haven't accessed anything, that I haven't really used anything with this user. You can go and search for a specific service. So you can see that for S3, it can actually dive in fairly deep. It can actually show you exactly the permission level of what I'm using, what I'm not using. Unfortunately, it does not do this for all services. You'll notice that most services, it does not know how to dive into exactly the permissions that are being used. So it's fairly high level, but it does give you, again, a sense of what that user is doing, what he isn't doing. But again, it has its limitations. If you remember, we've been talking about the fact that almost everything, all these tools are focused on really the user and his presence, I'll call it that way. But it doesn't take into account what that user could do once he actually assumes the role. It does not track that whatsoever. So if I do make all my changes via the role assumption, so using one of the roles that we showed, it wouldn't be demonstrated and it wouldn't show up from here. Any questions so far?
So there's a request if you can a little bit like zoom in, increase the font size.
Sure.
Yeah, it should be fine.
Is this any better? Kind of makes it a bit weird, but sure. So what we did was, again, we looked at Access Advisor and we looked at basically all the different services. I called out specifically S3, just I'm doing this again, just zoom to show you that S3 does have a deeper, so Access Advisor specifically for the S3 service has a deeper understanding and you go down to the permission level to understand what I've been using or what I haven't been using from a permission perspective. For all other services, it's not that deep. It just shows you if you touch that service or have not touched that service. So basically, even if I have full administrative rights on EC2 as an example, we'll look at EC2, okay? It's gonna show me that I have administrator access to it. I have not accessed it, but let's say I did access and all I did was just list all EC2s. It'll show me as if I used it and as if I'm using all the permissions or everything that I have, which is full admin access to EC2 in this specific case, which is misleading because in practicality, I'm not actually using all those permissions. I'm using just one permission, which is list all EC2s, which is, again, something that when you think about the concept of least privilege, you would want to minimize my permission to just what I am using and not actually have me stay with full permission. So how do we get past this and how do we actually start finding out more around what a user is actually doing? So AWS has another service called CloudTrail. CloudTrail is basically a log, and it logs everything that has been done or everything that really, well, you can see everything that's happening within your environment. So CloudTrail is very, very useful, but just like any log, you have to be able to parse it. You have to be able to read it. You have to be able to know what you're looking for. So we can go here to the event history. It'll show me all the different events. I can do a little bit of searching. There's not a lot of search functionality that really is available directly from here. But Amazon does offer, AWS does offer services like Athena, where you can run more advanced queries. Note a few things about CloudTrail. CloudTrail, the first CloudTrail in every account is free. So activate it, run it. It's important to have it up and running. But then they start costing money the more and more CloudTrails that you actually have. Then Athena itself is very expensive. Athena itself, I don't remember the exact price, but there's like a price depending on the amount of data and the type of query you're running. So there's a lot of cost associated to it. And it's something that we see a lot with customers not knowing this, that it kind of beefs up their AWS bill by having multiple CloudTrails log the same thing over and over again. So just note that. But our general recommendation, and I would say right here, is have CloudTrail. CloudTrail is very useful. CloudTrail will give you the visibility that's needed in order to understand what's actually being done, what a user is doing against what service, what he's accessing. It shows important logs like a service assuming a role, as an example. So have it, even if you don't search for it, it's good for auditing purposes. It's good for really understanding what happened in cases of disaster, or just in general to really see what's going on. So CloudTrail, that's really it about CloudTrail. Any questions so far?
Yeah, is there a like auditing feature to see from the resource point of view, see who is accessing it, what are the requests being denied, those stuff?
So CloudTrail will show you all that.
Okay.
Yeah. So CloudTrail does all that. Now, there's no like magic button where you can show me everything. I wish there was. If there was, we probably would have a harder time selling our solution. But really, CloudTrail is the main resource for all that information.
Sure.
Okay, so we talked a little bit about CloudTrail. And I mentioned the fact that CloudTrail can actually show you role assumption. Now, one of the biggest issues with roles is, as you remember, and I'll jump back into our role. So if we go back to our role, if you remember, this for demo role admin had two entities that could actually assume it. So we talked a little bit about federation, and I think federation is really a good thing to talk about here in this case. You could have multiple entities be able to actually assume a role. Now, all of them, if they act, will act as if they're that role. There will be in CloudTrail a log that says that this entity has assumed it, but there's one log. After that, everything is logged as if the role has done it. So there's a lot of tracking that has to be done in order to really understand the behavior of a role, because it can have multiple. So that's why I'm jumping back to federation. Federation is very common. A lot of organizations that we meet and a lot of organizations that we talk to and our customers are using solutions, IDP solutions like Okta as an example, in order to have their identities exist within Okta and be able to federate into their AWS environment. That leads to basically a lot of identities using a single role in order to actually interact with AWS or manage or do whatever they need to AWS. Now, that makes understanding and logging everything that happens a really, really, really hard task, because you have to find who assumed that role. And for Okta, it's completely different than an internal service assuming a role. So it's just sort of to emphasize, it's a bit of a mess, and you can get lost there really, really easily the moment that you have multiple entities that can assume a specific role. So that's something that you always have to take into consideration. Now, again, it's simpler if you have like two EC2 servers that can assume a specific role and then act, because you'll have the CloudTrail log. But once we're talking about external providers, it's a much harder task to actually understand and actually well, fully build out than internal. So if we want to understand this really, other than CloudTrail, there's no real way to do this that is really easy. We can use Access Advisor on the role itself, but Access Advisor is really going to tell us anybody that is trusted by that role, what they've used and what they haven't used. So trying to minimize the permissions of a role becomes a harder task the more entities that you have associated to it. So just always remember and take that into consideration that the best method, just like with the user, is looking at Access Advisor to get a general understanding and then having to go back to CloudTrail to fill in a lot of the gaps, unfortunately, to really understand what is being used by what user, and really trying to tie that all together to get the most accurate picture of, okay, what is this role actually doing? What is it accessing, and who behind that role is actually accessing that? You might want to consider really this concept that we call role splitting, which is basically taking a singular role and splitting it into two. So each identity behind it has the permissions that are fitted for it. I'll try to give an example. Let's say myself and someone else have access to a role, or could basically assume a role. I only work with EC2, he only works with S3. That role, if both of us have access to it, will contain full permissions to EC2, full permissions to S3. But effectively, I don't need the S3 permissions, he does not need the EC2 permissions. And you're holding this identity or this really this role that has a lot more privileges than it actually needs. So the right thing to do here would be to actually split that role into two. Now, again, using the tools that AWS provides, you would first come to the Access Advisor, understand that both EC2 and S3 are being used. And then from there, you would have to go to CloudTrail in order to track the logs and look at exactly what's being used on each and every one of, from each and every person that is accessing that specific role. So we kind of looked at everything that AWS offers. I did again a high-level overview of really the identity types within AWS, how they're connected one to another, and really what's available from a tool perspective to kind of help you understand what's going on. So what permissions your user holds, what permission a role holds, who has access to resources, and so on. Any questions? Again, I'll pause so far.
No questions, sorry.
Okay, so what I'll do now, and now I'll actually pivot back to, our product a little bit. Now, so hopefully the last like 45 minutes or so, the problem of managing identities and managing permissions and eventually achieving least privilege, and how hard it is, specifically we talked about AWS, this is true to almost all cloud providers, understood how complex it is. And that's really why we started Remediate and why we think Remediate is the right solution to really come and help with it. So talking a little bit about the platform, and I'll do one slide and then I'll show the platform just because I think it's better. The platform is really focused on initially giving you the visibility that you need in order to understand all the different entities, all the different humans, all the different machines, all the different roles, everything that you have in your environment. So making it very, very easy to understand that. Then after that is analyzing all that data in a way that fully demonstrates to you what is being used by who, who's accessing what they're not using, what they are using, all the different relationships. So basically everything that I tried to cover in the 45 minutes for really what we covered was 2 roles, 1 user, and 1 S3 bucket, but at a much larger scale. Talking about almost an endless amount of accounts with an endless amount of resources and an endless amount of services within them. Then once we have all that analytics in place, it's really coming and trying to enforce policy. And the idea behind enforcing policy is really achieving that least privilege. It's minimizing the permission set so you're only running with what is actually needed and what is actually being used. That allows you to be effectively as secure as possible without really compromising your work. Now, where we are unique, I would say, is the fact that we wanted to work from the moment of discovery all the way to actually remediating the problem. So we want to discover the issues, but we also want to help you fully remediate, and I'll show that. So we do offer automation out of the box that basically can come and fix the policies, improve upon the posture, and actually get to that least privilege state. The last portion I won't dive into too much, but because of the level of visibility we have, it's very easy for us to really look at compliance sets. In the demo, I can show CIS and really show you how you mark up against that standard and where you fail and what misconfigurations are present within your environment. So jumping back to the browser, we'll go to the Hermetic platform. So what you see in front of you right now is the Hermetic platform. We're looking at our demo account that has two two accounts connected to it. So right now, the dashboard is showing you an aggregated view of basically everything that is present within those two accounts. I'm going to pause. Is this zoomed in enough, or do I need to zoom in here as well?
Yeah,
okay.
Looks good. Yeah, yeah.
Okay. Okay. So we can see that we basically have top widgets that we call the inventory widgets. So they really talk about what's the inventory, like what do we have in this environment or in these two accounts. So we can see that we have 41 users, and if I click it, it'll take us to inventory, AWS, and to the IAM users, and I'll be able to get a list of all the users. This is still not unique. AWS offers you a list of all the different users that are there, but to view two accounts in one, you have to go and actually log into both accounts and then see both. So already the aggregated view brings you additional value, so you can actually see the full everything that you're actually managing. Then really we can go and start diving in for every identity to understand what it can or can't do. So starting off with the permissions tab, we get a very easily understandable queue of what policies this user has associated to him, and then what services he has available to him. This does include basically calculations for all the different types of policies that we talked about: the inline policies, the managed policies, the AWS managed policies, boundaries, service control policies that I didn't really go into but are present in there, roles that user can assume if he can assume roles. So all that is present, and basically we show you the effective services that he can actually access with full understanding. So we said that S3 AWS can do as well. Let's look at like Lambda. We can actually show you exactly the permissions for each Lambda function that is being used by that user has access to, and exactly what he can or can't do and what he is doing or what he isn't doing. Now, to emphasize, this is just the visibility. This is not where we expect the user to come in and kind of go like, okay, so I want to see what, I want to fix everything and go user by user and do this. So really, this is just the level of visibility that we can actually, sorry, is there a question?
Yeah, yes. So here, these 41 IAM users, these are the users who are created in the AWS platform itself, right?
Yes.
So there can be a use case that I don't define all my users in the AWS. I define all the users in the AWS administrators in my LDAP. Let's say, for example, right? And then so they may have their own enterprise roles in my LDAP, and I create a mapping for those roles to the AWS roles. So when I federate those users to the AWS, I do the role mapping, and they will get an AWS role, and they log into the AWS console with the AWS role, right? So now, is it possible to use this platform, to link this platform to my LDAP and point to a particular user in my LDAP and see what functions or what are the things this particular user can do on AWS?
Yes, so that I moved, I don't know if you noticed, but in this demo we have Okta connected.
Yeah, yes, okay.
So I'm basically showing you all the different Okta users that we have. And then I can show you one-to-one exactly the same image of here is the user.
Okay.
Here's the role that he can assume. So you can see there's two roles. The reason they're grouped up is because both roles contain the same policy. But if they were different, we would actually break it apart into two different roles and what they can give, and then basically all the different services that he can actually access. You can
So
see
how,
this guy. Sorry.
sorry, how easy to add another IDP? Like, so this is linked to, I guess you are using some Okta APIs, right?
So we support other ones. It's not just, this is just Okta. We support like Azure AD as well. So it just depends on what you have. We don't support everything. I'd be happy for whoever asked the question. We can talk about his specific use case and exactly what he needs. And hopefully we cover it out of the box, but if not, it's something that I'd be happy to understand more of and see how common it is, and then understand if it's something that we can add to our roadmap.
I think this is the view, like one of the views missing in the AWS, right? Because AWS cannot create this like enterprise user to the resource mapping. They will create a role to mapping, right?
You're absolutely right. This is, I think, one of the most valuable features that we have currently in the product is the fact that we can actually integrate against external identity providers, and bring this back to this singular view that shows you from end to end what they can do.
So do you also support Azure and other cloud platforms too?
We do, yes. Again, the focus of this conversation was AWS, so I'm showing an AWS demo, but we do support other cloud platforms.
So in that case, like, so if I click on one of my enterprise users, I should be able to find that aggregated view of all the permissions assigned to this user from different cloud providers, right?
Yes.
Okay.
So jumping back a little bit to the inventory side, I'm kind of walking backwards from what we showed, but like policies, we talked about the fact that policies or inline policies are not centrally managed and you have to go user by user. A little bit of another small value that we give is the fact that we do look at all policies. And you can come in and say, I want to look at all the inline policies that I have. We show you exactly what they're applied to. And then you can actually come in and say like, okay, I want to understand what this policy does. And we'll do the same breakdown. So in this case, this is a simple policy. You can see that it basically just gives access to Cloudflare Clause. And it's not even being used. But as I said, we do this for pretty much everything. So a common question that we always get from customers is like, I want to understand who has access to S3. No problem. You can come here and look at the service level. And we'll select S3. And we'll go to the permissions graph. And now this is going to be very large. I'm already warning. So you can see basically all the different entities that have access to, this is in general to S3. We can do this to a specific bucket as well. But you can see all the different entities. You can see there's roles. You can see there'll be machines. There'll be everything here's the machines. You can see here's an EC2 instance that can assume a role and has access. An easier view would actually be just this. These are basically, you have 106 identities that have access to S3 in this specific case. And they're ranked from the most excessive to the least excessive. So we can see that some of the stuff here is not excessive. So we do that calculation for you for any given service. Now
we can edit AWS policies from here too.
To a certain extent, and I'll explain. So I'll explain that in a minute.
Okay, sure.
For other data, other visibility sources are like, this is a very powerful, window as well, a very powerful feature. We call this identity intelligence. This is where you actually can see all the different identities within your account, and actually sort of understand the risk factor associated to that identity. Now, risk factor is not necessarily if they've done anything wrong, but it's how risky that user is if he gets, let's say, for example, breached. Now, interestingly, we actually tag it with what we call labels to make it a bit more clear as to what that user has. So like one of the more interesting ones, and we talked about this, is like, I want to understand all third parties that have access, all identities that are used by third parties. And we can see right away that we're seeing their medic role, and we can see basically all the third parties that are present within my infrastructure. And there's 27 of them, right? There's 27 different third party identities. Now, going to your question about changing policy, so let's take like Dome 9, which is a cloud security posture management tool by Checkpoint. We can see that it's a risky identity. We can go in and see its permissions, but what I really wanted to show was the findings. Findings are sort of alerts. They're what we found that needs to be well fixed within the environment. So if we go here, we'll see that this role has excessive permissions, which is obvious just from the graph. And we'll click on it. We'll get all the details around the excessiveness. Like we'll see how long he's been around, what permissions he has, and so on. And we'll get the graph that show what he's using. But really, where we can interact with policy is down here. You can see that what their Meta platform does is it actually gives you 4 remediation steps to really rectify whatever we found was the gap here. So we're making a first suggestion is to create a new managed policy. And we're giving you a side-by-side view of what the current policy is and what our suggestion is. So you can see that we're removing some, we're modifying, like here, the Dome 9 read-only policy has full access to all S3 list permissions. We're suggesting, hey, he only needs this permission. And you can see it goes even more and more granular as we start going down into what he needs and what he doesn't need. Like we're calling out specifically, he needs IAM get role and he doesn't need full IAM access, and so on and so on. But we do offer full remediation. So you can just click a button and basically at that point, we would actually make the changes for you. To answer that question fully, you can't come here and manually edit policy. Like we don't give you a policy editor. AWS does a terrific job about that, both via API and through console. But you can modify policies via our findings. There is an option also to integrate with like a Terraform and CloudFormation, so you can actually do this via your CI/CD pipeline. But that is the integration of how we would actually fix policies so we can get to that least privilege state.
Sure. There's another question from Frank. What typical real-time granularity does the hermetic system have to the effective IAM configurations?
So if I understood correctly, we are connected to your environment. So we are basically a third party that has access to your environment. And at that point, we pull the environment at regular intervals to collect the data. From a permissions perspective, we don't hide it. We're happy to always show. There's 2 levels of permissions that you can give to an account. And again, this is just for AWS, but you can give to an account basically what we call read-only permissions. And you'll notice these are basically the permissions that we need for IAM on the read-only side. And then if you want the auto-remediate function, there is a secondary set of permissions, which is much more, I would say, wide, because we actually have to make changes to the environment. And you can see that there is basically, at that point, we're effectively administrators on the environment. So it just depends on the comfortability level. But again, our solution is a SaaS solution that connects to the environment via a role, pulls it, takes the data that it needs, does the calculation on our end. So there's no additional cost on your environment. But the level of permission really depends on the comfortability level that you have with it.
Sure.
There's a lot more that I could show. I kind of only really scratched the surface of the product and what it does. On purpose, I didn't want to invest too much time in it, and I wanted to kind of talk more about AWS and what they offer. But I'm always happy to explain more, talk more. So I'll kind of stop there and see if there's any other questions.
Yeah, maybe like what other competitor solutions we have like similar to this one?
So you're asking who our competitors are?
Yeah, like so you are solving some like very important problem, right? Especially like so when people are moving to this multi-cloud environments. So what other computer solutions you see in the market similar to this?
So luckily for us, both Gartner and Forrester have coined markets for this. The Gartner one is called KIM or SIM, but with a C, CIEM.
Yeah.
They actually included as part of that, like the competitive landscape. There's a few competitors in there. So like I would call it the new age competitors that we see in there is a company called Sonri. There's a company called CloudKnock. There was a company that just got acquired by Varonis called Polarize. For some reason, they included Obsidian security as part of that, but Obsidian does nothing to this extent. Obsidian is a lot more threat focused. Like they focus on finding threats within your cloud infrastructure, not finding permission gaps. And then you have the I'm going to call them the older age competitors, which is like Savient, SailPoint, and CyberArk. That's really pretty much everybody that's there. There are some newer ones popping up now, but I'm not really familiar with them too much. I still haven't done my research around them. The ones that I mentioned, I do know fairly well, and we know that they are competitors, and hopefully we have an understanding of where our value is versus where their value is.
Sure. Yeah. I think that's all the questions we have. Anything else you want to cover, or?
Like I said, there's a lot more that I can cover from a product perspective, but considering I didn't want this to be a full, like, very deep demo of the product, I'm going to stop there.
Okay,
and of course, offer anybody who's interested and is watching and wants to see a demo, you can reach out to us at our website, and I'm sure one of our talented personnel will reach out and set up a private demo and talk about your specific use cases and what you need.
Yeah, so thanks a lot, O, for the very informative session, and also for taking all the questions and very good sort of demos. And thanks a lot, everyone, for joining in, and looking forward to meet you again in the next meetup. Thank you very much.
Thank you.